We've got Kevin Shinpaugh, who's the Director of High Performance Computing at Virginia Tech. He's going to be talking about GPU computing and computational sciences.
So basically, we provide the central IT HPC resources for Virginia Tech. And surprisingly, we actually have over 200 users on our systems, probably close to 300. And some of the users are even around the world. So it's anybody who is collaborating with Virginia Tech can access our systems. We're actually part of the IT department, but the person I report to also reports to the research division. So we got the tie-in with both the IT and also the research division. And recently, Virginia Tech has, we've actually started getting base funding for HPC at Virginia Tech, which is usually pretty rare. A lot of times you have to go out and get money from NSF and et cetera. So the university is really committing to HPC and trying to do it at the base layer of funding. We have our website here, www.arc.vt.edu, and ARC stands for Advanced Research Computing. Kind of give you an idea of what our users are doing at Virginia Tech. We have a very large group that does fluid mechanics, so about 23% of our cycles are consumed by them. Also, we have a very large materials group as well. And then there's also a very large Virginia Bioinformatics group, which my colleague over here represents. Some of the machines that we have available at Virginia Tech, some of you might have heard before. How many have heard of SC10? It was the big Mac cluster from 2003. It's still running actually here at Virginia Tech. It's on its 7th year, so still heavily used, and hopefully next year we're going to be replacing it. The machine here I'm talking about to you today is the Athena, which is our data analytics cluster. Basically, it has a hybrid computing model. There's some of the nodes have GPUs in them, and then some of them are just regular compute nodes. Very large, fat nodes, 32 cores in a single system. Of course, I did mention System 10. At one point, it was ranked number 3, and then at one point number 7. But hopefully, we're going to replace it next year. And it basically provides a large MPI application set. So when we looked at our new system, we actually get money from the state, and that money comes through the, it's called an educational trust fund. So the state provides money for research, and from there we had a certain amount of money to spend. What we had to do was put in our requirements several months before they actually award the money. So we had to, in August of 2009, we had to give the state that we wanted to buy a certain amount of equipment. We actually didn't get the award until almost 6 months later, and so the state, said that, okay, you can spend this money to buy this system. So we had been talking to Appro and James River Technology, and originally we only had 2 days to get the quote together to originally put the placeholder in for the state system. So Appro was very capable of turning around a quote for us very rapidly. And so there we were looking at technologies. We wanted to see what technologies would be available in the time frame we were looking at. So AMD was coming out with their new processors at that time. Also, the NVIDIA Fermis were also supposed to be slated coming in probably around the April-March time frame. So Appro was very willing to commit with us and to meet our needs. And basically, we're looking at providing visualization for our users, also to provide a test bed for GPU computing. One of our researchers, PI Wu Feng, recently won an NSF grant where we're building a very large GPU-based system. So this is kind of a test bed for that system. Also, if you look at a lot of the ISV applications like Fluent and stuff like that, we also wanted a place for those things to run very well on a single node. If you look at a lot of them, 32 cores works very well for Fluent. So just kind of keeping it all in one node so they don't have to do a lot of traffic back and forth. So we ended up with this system called Athena, and reason why we adopted Appro, they were very willing to work with us on delivering the AMD processors and also the NVIDIA Fermis in the time frame we're looking for. So basically we ended up with a 42 node system. It's quad socket, 8 cores, and it's based on the AMD Magna cores. We actually have 32 NVIDIA GPUs in the S2050 platform. And so primary purpose is for people, again, to test their GPU applications. We have researchers that are looking at adopting GPUs for the research. VBI here at Virginia Tech is also doing that. And so this kind of is a test bed for the future for when we bring in this larger NSF-funded system. So it has 2.6 terabytes of memory, and it's also based on the quad data rate InfiniBand. So our key applications, again, are visualization, data-intensive computing applications, and also providing the ISV applications like Fluent, etc., Abacus, etc. And then also the future testbed for our GPU computing platform. One of the other things that Appro was able to work with us, our sysadmins are from the kind of enterprise sysadmin space. They're very used to having things very, not having to build a lot themselves. So we had looked at various cluster management suites, and Appro actually recommended that we look at Bright, and we looked at it, and our sysadmins are very, very happy with this product. So this is probably what we're going to end up standardizing on our computing platforms for management. Now, part of the, when we got this money from the state, we also had money available to also upgrade some of our visualization computing systems. So we had an old cave that was from the mid-1990s that had been still running on the same SGI hardware for the last 15 years, and also with the same video equipment, etc. So part of that money upgraded our system. So the thoughts here for Athena is using the GPUs, either through ParaView or Visit, push the rendering back out to the cave system or wherever the users need it. Everything else resides inside our data center, so we have multiple systems. They can generate their results, do the rendering on Athena, and then push the results out to either their system or out to the cave, or etc. So this is the, we're now calling it the VT Virginia Tech Visionarium. Recently we upgraded all the equipment. It's a 4-wall cave. Now we have 2 projectors per screen, and it's now being rendered by a much higher end Linux cluster instead of the old SGI system. Just kind of a view what's going on. Here's our director of visual computing, and they're just playing around in the cave. Some of the other people that are also working on looking at GPU computing, there's the group out of Virginia Bioinformatics. It's the NDSSL, which is Network Dynamics Simulation Science Laboratory. And basically they're interested in looking at something like bird flu or something like that would spread through a population. So they can model the social interactions between people, also how a particular virus might spread, and then looking at how that might... so here we're going to see a simulation where you'll watch a flu outbreak in Montgomery, Alabama here, and then they'll also look at if we vaccinate a certain portion of the population, how does that change the spread of the virus? So you can see it here. We have a very large outbreak in Montgomery. Here they've taken the steps where they started vaccinating a certain amount of people. And you can see it rapidly spreads when there is no vaccination. Here, very minimal spread. It's just breaking out in very small sections. And so using something with a GPU, they can actually model this much faster, and they also might be able to look at more social interactions. So some of the questions they're trying to answer is, can they moderate the breakout of a virus or spreading of some sort of a contagion? What if there's not enough medication? What would be the best plan on handling that? So would you want to vaccinate large population centers or rural areas, etc.? So xtreme-x is the name of the program they're using. And so again, just the basic methodologies of how xtreme-x works. And the key question they're looking at is it worthwhile to vaccinate or not to vaccinate the particular population? Here we can see that they did get, if you look at a single CPU core with the GPUs, they are getting a speed up. And right now there are some more optimizations that they will need to do to get better performance. But they also can end up doing more modeling on the social interactions with a GPU. Another one of our users also have seen a speed up of almost 9 times on meteorological code. So when we deploy these larger systems, a lot of our users will be ready for these with the GPUs. So future plans, I mentioned that the National Science Foundation awarded Wufeng and MRI on using large-scale GPU computing platforms. And so we expect this system to be going in place in 2011. And then hopefully also in fall of 2011, we're going to replace System 10. All right, well, thanks for listening to us today.